Hey, eighth graders, this is your test review. So you have a test on Tuesday of this week, so make sure you take it on Tuesday. Wednesday, you need to use as a makeup day. So any work that you haven't finished for the semester, make sure it's all due by midnight on Wednesday. We have to finalize your grades early Thursday morning. And so we can't change a grade after Thursday. So make sure you get all your work done. So hopefully you guys printed off your practice problems and you can either, hopefully you're checking your work at this time. If you haven't done it yet, go ahead and pause the video and get these done and then come back on here and check your answers. All right, so number one is about the Pythagorean theorem, because if we take this rectangle and we divide it, we would have two right triangles, and the same with this square. So some people think, well, since the side length has doubled here, that means the diagonal will double. So that's why the directions say to compare the diagonals. So we have to use Pythagorean theorem. So on this problem, we're going to say 10 squared plus 20 squared is our hypotenuse squared, or our diagonal. And on this one, we have 10 squared plus 10 squared is our hypotenuse squared. So 10 squared is 100 plus 20 squared is 400. And that's going to equal our diagonal, our diagonal squared. So let's just put 100 plus 400, which of course is 500, and then the square root of 500 is 22.36 inches. So since this length was doubled, let's see if it's double, the diagonal is double. All right, so 10 squared is 100, and 100 plus 100 is of course 200. So the square root of 200 is not double, right? 14.14. So 14 squared, 14 doubled, of course, would be about 28. So it's not quite doubled. All right, so anyway, so if they want us to compare, one way to compare is by saying, okay, well, how many times bigger is one than the other? So one way to figure that out is we could divide 22.36 by 14.14, and we could say it's about 1.6 times larger, 1.6 times larger, or longer, because we're talking about a length, right? So the bigger rectangle's diagonal is about 1.6 times longer than the square's diagonal. Number two, if one side length of a wall is 13 feet, what would that diagonal wall have to be if it were a square? Well, if it were a square, what would that mean? If this side is 13, this side would what? Have to be 13. So if both sides are 13, that would make it a square. So that means the diagonal would be the square root of 13 squared plus 13 squared. So what is 13 squared plus 13 squared is equal to, oh, and I took the square root of that. I just typed the whole thing under the radical, and then it does everything at the same time. That means the diagonal would have to be about 18.38 feet. So if this one side were a part of a square wall, then the diagonal would have to be about 18.38 feet. Number three, a local ice cream shop offers two choices of containers for ice cream. A customer can choose either a cup or a cone. The two options shown below have the same radius and the same volume. What is the height of the cone? Well, the only difference in these two formulas is 1/3, right? So if these two containers have the same volume, then that means we can take this formula and set it equal to this formula. So the formula for the volume of a cylinder is pi times r squared times h. And for a cone, it's 1/3 times pi times r squared times h. Well, if we wanted to get the h by itself, we could divide both sides by pi r squared. Pi r squared. So pi divided by pi is 1, 1, 1, and 1. So what are we left with? We're left with the height is equal to 1/3 times the height, right? And then to get rid of this 1/3, we would multiply both sides by 3. That means the height of the cone is 3 times the height of the, cylinder. Well, if the cylinder's height is 4, that means the height of the cone has to be 3 times 4, which is 12 inches. So for these containers to have the same diagonal, not diagonal, but radius, and they have the same radius and the same volume, then that means the height of the cone must be 3 times taller. Okay? So that's what it means. If they have the same volume and the same radius, that means the height of the cylinder is 1/3 the height of the cone. I hope that makes sense, you guys. So the height of the cone is 12. All right, number 4, find the length of the missing leg. That should not say leg, that should say side, because this is a leg, right? So we have two legs and we have the hypotenuse. So we're gonna say 2 squared plus x squared is equal to 3 squared. Well, 2 squared is 4. And 3 squared is 9. So then we're going to subtract 4 from both sides to get x by itself. So we would have x squared is equal to 5. And then how do we find the square root of x? I'm going to take the square root of both sides. So you could say the length of that leg is the square root of 5, or based on the directions, it could ask you to round to the nearest tenths. So you would say that it's about 2.34 inches. That leg is about 2.34 inches. All right, number 5, we do have the 2 legs and we are missing the hypotenuse, right? So that would be C. So we are going to square both legs find our hypotenuse. So this would be 25 plus 25 is equal to c squared. So that would be 50 is equal to c squared, and to get c by itself, we find the square root of both sides. So you can either say that c is equal to square root 50, or we could say square root of 50 is about 7.07 inches. The hypotenuse is about 7.07 inches. Okay, what about 5b over here? If we are given 2 points on a coordinate graph and we want to find the distance, then we are going to create a right triangle, either by making a right triangle below or above the line. Either way, that's going to be our hypotenuse. So then we see how long or how wide this triangle is. So we have 1, 2, 3 units, and here we have 1, 2, 3, 4 units. So our legs are 3 and 4, and that's going to equal our hypotenuse squared. So 3 squared is 4. No, it isn't. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So is the hypotenuse 25 units long? No, the square root of 25, which of course is 5. So this length is about 5 units long. All right, number 6 says give an equation for the Pythagorean theorem using side lengths. So look at our side lengths over here. So we know that these two sides of this triangle would be the side lengths, the leg lengths, right? So that means that side AB squared, so this is side AB squared, plus side what? BC squared is going to equal what side length? AC. Line AC squared. So that's all that means. You have one question that's something like that that asks about side length. So basically, just seeing that example will help you understand that question. All right, number 7, to get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 3 meters south. So you got to walk 3 meters south and 10 meters east. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? So what if they made a little bridge across the pond? What would be that distance? So just like all the other problems we're doing, Pythagorean theorem. So we're going to square 3. So 3 and 10 are the legs. We're finding the hypotenuse. So 3 squared is 9, 10 squared is 100, and C squared is 109. So of course we take the square root of both sides. And that would be about 109, would be about 10.44 meters. All right, and once you get these answers, always make sure if you're finding the hypotenuse, make sure it is in fact the longest number, the biggest number. If you're finding one of the side lengths, make sure it's not the biggest number. All right, what about number 8 down here? What is the volume of a sphere with a radius of 6 inches? So a sphere, the volume of a sphere is 4/3 times pi times the radius cubed, right? So hopefully you guys have those formulas written down somewhere. So if we have a radius of 6, so we're going to find 4/3 of, let's multiply by 3.14 and multiply by 6 to the 3rd power. And one thing about these calculators I love, you can just put that straight into your calculator. 4/3, the fraction, times 3.14 times 6 raised to the 3rd power. And I know you have a pi button on your calculator, but just to make sure we all have the same answers, don't use that. Let's just, unless it tells you, we're going to always use 3.14 for pi. And so the best answer without using the pi button is 904 32/100 cubic inches. That is the volume. Got that by plugging it straight into our calculator. All right, number 9, look at these cups. How many more cubic inches of juice could cup B hold than cup A when completely full? Which means, of course, we have to find the volume of both. So we have our cylinder, and for our cone, it's the same thing, except at the end we divide by 3 or multiply by 1/3, whatever, same thing, right? All right, so let's find the volume of the cylinder first. So we're going to do 3.14 for pi times half of 2 is 1 because it's the radius squared. So 1 squared, which of course is 1, times the height of 7. So basically, it's 3.14 times 7, which is 21.98 inches squared, or cubed, sorry. No, it is inches cubed. Yes, volume. Did I do one earlier and I said cubed? I think I did. No, I didn't. We were doing the height. Anyway, now let's do the volume. So once again, the radius is 1. So 1 squared is 1. So we're going to do 3 times 3.14, 3.14 times 3 times technically 1 squared. So 3.14 times 3 is 9.42. And then to find how many more, we're going to subtract 9.42. When we subtract, we get 9, 10, 11, 12 cubic inches, 12.56 cubic inches more. So that's how much more the cylinder can hold than the cone. All right, you guys, I think that's it. Yes. So just as long as for this one, it looks like we need surface area, not surface area. Looks like we need volume and Pythagorean theorem, and hopefully you guys got that. If you need my help, please let me know. We can go over any problem today that you need. Take your test on Tuesday and make sure you get all that missing work. Hopefully you don't have any. You shouldn't have any at this point. But if you do, make sure you get it all done by Wednesday night. All right, you guys, if I don't talk to you again, or if I don't see you on a Zoom meeting, then I hope everyone has a wonderful, wonderful Christmas and Happy New Year. And I will talk to you guys soon.